Thank you. All right. I think all the spaces are pretty much occupied, but there's a huge area here and there's a huge area here. So if you're feeling comfortable sitting on the ground, feel welcome to sit down. Only if you're feeling comfortable, of course. All right, we're going to speak about hindsight lessons about API testing. That's a very, very terrible topic for the morning. It's a tight hole. I heard this a couple of times yesterday, a tight hole, a small hole. I'd prefer calling it a room, otherwise people might hear something dirty. Anyway, we're going to talk a little bit about API testing and what is a hindsight. Hindsight is normally a lesson, or it's actually a bias. In psychology, it's a bias that we are saying something, estimating something in the past, like saying, I expected that Trump would win, or something like this. We are always giving this huge importance to our opinion about something that's already in the past. But what I meant when I was coining this term hindsight lessons is that I wanted to share lessons that I wish I knew before I screw them up very bad. And I made this short series called Hindsight Lessons about Automation. So if you're interested, you can go to my blog and review them. So in short, we are going to speak about API testing and sort of the lessons that I learned about API testing. I don't consider myself expert in API testing, and in fact, I hate giving presentations that are so close to practices and tools. I spoke about that a couple of times, that I don't like the approach of practices and tools. I like the approach of thinking strategically about testing. But anyway, so first of all, we have this sort of agenda. We will speak about a little bit what is an API, but I'm not going to dive into too much explanations of what API is. So if you're expecting sort of an introductory lecture about what APIs are or what web services are, I'm the wrong guy to give it to you. So we are going to speak about testing, hardly about testing. Also, some serious cognitive barriers that you're going to meet whenever you're trying to test APIs or test APIs using some toolage. We are going to speak a little bit about what tools or what tests are worth automating. This is something that I was having a hard time finding out because there's not a lot of information, not a lot of interesting stuff about this. A little bit about our setup and environment, because this is needful information according to context, and a little bit about the framework that I built. Now, first of all, something that I wish to clear out before we start speaking about testing is that we are at an automation conference. Normally, ISTA started as an automation conference. It grew into development conference and DevOps conference and all this stuff. But please don't treat tools as solution. Tools are tools. Tools are serving you to solve a problem, but they're not the solution of the problem. So don't expect them to solve a problem for you. You are the one who solves the problem. So tools don't create software and tools don't test software. Therefore, we are going to only speak about what is useful for us. How do we test software using tools, not the other way around. A little bit of a bullshit warning, something that I see as a trend in conferences, and I don't like doing it, is I don't like hearing a how-to. Very often at the conferences you're hearing some sort of, people try to make a practical talk and they're practically making a how-to, very, very shallow how to use this tool, how to solve this problem, etc. So, I'm not going to give you a 30-minute introduction. I have plenty of time, but I'm not wasting it in giving you 30 minutes introduction about what APIs are. As I said, it's not an introductory talk. So if you're unfamiliar with what services are, you might go and look at Google or look at some resources about what it is, but we're going to focus on testing. I'm not going to try to make my life miserable by doing live coding. I don't know why people do this in front of other people on stage. Like, I don't have to prove to anyone that I can code, or I don't think there is some satisfaction in seeing a test pass or fail on the stage. I don't know why people do this. There might be masochistic or something, I don't know. So, and I'm not going to give best practices. If you are a little bit familiar with my history, you might know that I have sort of a cringe feeling about best practices, and I prefer calling them practices. So, who am I? I don't know, just a friendly neighborhood testing troll. I am also a blogger. I work for a company called SiteGround as a senior QA, and that's practically everything that you have to know about me. If you are interested in my ideas or whatever I have to say or whatever I spoke at previous conferences, you can go to my blog and read more and find more interesting stuff about the visions that I have about testing. So, what the fuck is the web service? It's the ground that we have to build in order to speak about testing. What are services? Services are practically something that is very common in the internet. Practically everything that you're using is using some sort of services or microservices or whatever. And the way that I explain it to my students in the academy that I'm giving lectures to is normally imagine that you're having a waiter. A waiter is a really good representation of a web service. For example, when you're speaking with the waiter, you have this very limited protocol that you're using in ordering something. For example, you're reviewing something that you have like a menu, and you can only pick something from the menu. You cannot simply say, I want a Maserati. It doesn't work this way because it's not on the menu. So you normally give something from the menu, and this is your request. You're making an order, and this is your request. In web services, we are calling this a web request. You're also having a response. This response is normally a small digit code that's giving you information whether or not your request was successful. In the context of a waiter, for example, the waiter, you would ask for shkembe chorba, for example, and the waiter will say something like, yes, we have it, or no, we don't have it, or it's from yesterday, or he wouldn't mention it anyway. So, this is the response code or the status code, and you're having also the data that you're receiving, and in the context of a waiter, this would be the dish that you will be delivered to. And that's practically how web services are organized in a very, very high level. I really don't think that there's much more specific that you're needing right now in order to understand what web services are. A little bit about status codes. Status codes are something that's very convenient because it's giving us information whether or not the service actually provided what we asked for, or actually if it was successful. And I'm going to visualize it with the so-called HTTP status kits. By the way, this is a really good site. It's on the internet. You can go and find them. There's a cat meme for every status that's out there, and they're hilarious. So I'm only picking a couple of the basic ones. So the one that you probably already know is the 200 code. And the 200 code is normally just okay. This means that our operation was successful, that whatever we wanted for was performed. Whether or not we got the data, it's not sure. Another one, moved permanently, normally is displayed whenever there's something redirected. And this is the representation of 301. We are also having the 400, which means it's a bad request. What is a bad request? This is normally when we on the client end screwed up something coining the request. For example, we have to provide integer, but we are providing double value, or we are trying to provide empty value or no value or something, and we are getting error that is a bad request. And of course, 401, which is unauthorized. This is whenever you're trying to pick something that you don't have access to. Like, for example, you're trying to trying to list the credit card, but you're not logged in or something like this. And the star 500, which means internal server error, which normally means that something on server side screwed up very bad. So this is about status codes. I'm not going to mention anything about headers because they're normally metadata that we are transferring to, that we are sending in order to kind of figure out the communication, so we are not going to dive deeper into this. Of course, we should speak a little bit about the correspondence between CRUD and REST. Like every method in REST APIs has correspondence to the CRUD operations. So if you're a QA, you should be interested, or if you're a tester, you should be interested on how these are implemented and how do they work. Because if you want to be successful in testing something, you have to explore all the manipulations of data which are normally the CRUD operations. So why would you test the API? Why not do like the normal people who are normally creating tests in the UI with Selenium or whatever, something that's cool, something that moves your mouse, something that shows fancy stuff on the screen? So a couple of unobvious reasons, because I don't see a lot of people automating in the API. I see a lot of people automating in the UI. First of all, automating the UI is a terrible pain in the ass. I don't know if you ever experienced it, but it's a terrible thing to do. And there's a couple of good reasons why would you automate the API. So, for example, I created this as a part of the Hindsight lessons about automation. I created an article called Models of Automation, in which I'm also mentioning the famous automation pyramid. Probably you've heard it about a couple of times, or you'll hear it today like 1,000 times. And I was speaking about inverted pyramids, and one of them was the inverted pyramid of failure visibility. For example, whenever we are automating, we are having some layers which are really good for automation. For example, the unit and the integration layer are really good for automation because they're easy, they're definitive, they're code, and we're testing code with code. It's very easy to automate them. But we are not getting proper understanding what failure is produced and how this failure affects our users. So for example, if I get error that some function is not returning the correct value, I'm almost never having the clear idea how would this affect our users. It might break bad, it might just throw some warning, I'm not sure. Going higher the stack, we are having a lot of trouble and a lot of investment of time and resources in trying to automate, for example, the API and the UI, which is terrible in the UI because we are operating with a different interface, a human interface or a human-facing interface. But we are seeing the clear understanding what our failures are and how these failures are presented to our users. So a good reason to automate the API is because it's closest possible machine interface, which is closer to the users. It's also a very definitive response. When we were speaking about the waiter and the responses and the very clear protocol in which we communicate with the waiters, with the API, it's very simplistic. We are having very clear response, we have very clear payload, and we are having very clear response from the service, which we can assert in a very clear and definitive way. This is something very important, having your robust and really well-running automated tests. And it's easy to test with code. It's actually very easy because it was meant to be consumed by a code and not by human. So I'm not going to be a genuine ISTA presenter if I don't show the automation pyramid at least once. But by the way, I see that I'm kind of off trend because people are not showing the automation pyramid anymore. They're showing this thing with the monolith and the microservices and serverless. So I'm kind of outsider again. But anyway, old school, I will show you the automation pyramid, but I was not calling it automation pyramid. I'm calling it an automation iceberg or a testing iceberg, in fact, because it's testing after all. So normally people are only referring to, is that thing lighting? So normally people are only referring to that part here, which is the, and here, which is the unit test, the integration test, the end-to-end test. You can see it split, for example, in integration and web service tests and whatever. And I called it the iceberg because if the sea level is here, where you see that line, the thing that nobody is speaking about are stuff like context or test strategy or test mission or goals or purpose or test framing, oracles, like the cost and value ratio, reporting of your results and stuff like this. We should not forget, even for a single second, that in order to have stability here, we have to build our solid ground in the middle, in the bottom part. So if you don't have good understanding about testing, you don't have good understanding about your automation. Anytime that I was asked to give advice to a company or an individual about how automation went bad and how their automation was inefficient, I started digging in, and at some point I found out that they have very bad understanding about testing and what the purpose of testing is. So, in order to be a good automator, you should be a good tester, or at least have a really good understanding about what testing is. So, what's the setup that we used, and what's the context that I'm going to give you? I believe that what I'm going to show you is applicable for other frameworks as well. Anyway, I'm using the one that we were using for our project. It's called Codeception, and it's written in PHP because most of our code and the services that we are testing are written in PHP, and we had good reasons for legacy tests that we were having, mainly unit tests, to use a framework that runs PHP and is compatible with PHP unit. So practically we're having a RESTful API which was written in PHP. It was consumed by a React.js frontend. We were using Docker and Docker Compose for our testing environment, which was a great refresher. because we had this huge ecosystem of applications that were communicating with each other, and it was a huge pain in the ass to run them locally on your machine, to deal with all the fucking dependencies. And at some point we decided to containerize them, and it was a really good feeling to use it. We were using Codeception as testing tool. If you never heard about Codeception, it's practically open source tool that's using Selenium for some point. You have a couple of different functions that you can use. You can perform acceptance testing, which is practically Selenium tests. You can do unit testing, and you can do API testing. It uses the, I forgot the name of the pattern. Anyway, it has this actor class, which gathers all the actions that you can perform as a tester. And we are having also the custom tools to produce data, which I'm not going to disclose because they're kind of something that we created, but these are actually the thing that's most important for you, and they have to be something that comes from you and your internal knowledge. So what I would recommend is anytime that you try to perform something in automation, try to have a consultant from your colleagues that are in development, or have somebody of them assisting you creating supporting classes, because this is really good for creating and setting up test data or test conditions. So before we even think of testing, and before we even start speaking how do we test and what do we need to test, I'm going to dive into a couple of important notes. First of all, the cognitive barriers that we have trying to automate something. I see these very often at conferences. I see these very often at blogs and books. First of all, whenever you're automating, try to automate not tests that pass, but tests that tests. And that's very important. Many people are not focusing on this at all. Very often when automators try to test something, they test like developers. Developers normally try to prove that something works. They are only demonstrating the code and how it works. But the testers have a different mindset. We are trying to show all the ugly stuff about this software and all the ugly stuff about how it doesn't work. So in order to produce valuable testing, try to make tests and scripts and checks that are really providing value. The real good check is the check that makes the software fail. And it's another thing that we are saying wrong every time. We are saying our test failed. It's not the test that failed. It's the system that failed. The test was successful, actually. Because the purpose of the test is to find the bug, to find something that's wrong. So try to produce tests that are really robust, and try to expose problem in software, not just to demonstrate it. The need to explore. Don't kind of switch your hat to automator and never do testing again, because the most things that you're going to find out, this information, are going to be during your exploration of the API. So before you even start thinking about automating, just try to walk through your API, understand it, explore it, understand how it works, what's the sequence that all these services are called. Therefore, you know how they're consumed by your users. Otherwise, you're kind of blindfolded or narrow-visioned by whatever you're trying to produce as code. And of course, don't trust your documentation. The auto-generated documentation like Swagger or other normally sucks. It doesn't provide any feasible information. So I'd suggest try to consult your developers or discuss very often with them what this is supposed to do. And your coding skills are sometimes trying to hold you back from testing in a good manner. You probably know about the builder's mindset and the tester's mindset. The builder's mindset normally is try to build it and ship it and give it to somebody to try it. So when we are trying to build software to test software, we are going into every gap that a developer is having and every problem that a developer is having whenever they are building software. So be aware of this. Don't trust your own decision. Very often at conferences, I see testers presenting automation in a manner like, I am the tester and I'm writing the code, so I'm probably writing a perfect code. That's wrong, and that's the huge lie that you can believe anyway. So just try to think, how do you test it in a real life? So if you have a real application, try to explore it from the user perspective and then write the automation test, because otherwise you're going to go into all these gaps and all these normally developer way of thinking. So, what tests are worth automating? And that's the most important question that I was asking myself whenever I was trying to automate an API. But first, let's understand and think about what bugs are worth finding, or what bugs are worth testing for. What bugs are we normally experiencing in the REST services? So, for example, at least according to my experience, some of the problems that we run into whenever we were testing API was, for example, the service returning the wrong response code. Normally, that's just throwing 500 or throwing 400 whenever we are expecting it to throw 200, therefore giving us error whenever we are expecting correct behavior. Sometimes it might be returning wrong data. Like, for example, I'm expecting the array with the credit cards, but I'm only getting IDs or something like names or just strings or whatever. Or we are not getting any data at all, which is terrible. Like, we're getting the correct response code, but we're not getting any data out of it, which for a GET service, for example, would be a terrible idea. And some sort of interaction problem, like, for example, we're calling one service, we're expecting some data out of it, but it's not accepted by another service that's consuming it, and that's terrible thing to happen normally within integration. So these are the problems that we are focusing on, and what checks are we going to produce in order to hunt for them, so to say. Well, I reviewed a couple of resources. There's not a lot in the internet, and there's not a lot in the space. So I reviewed a couple of them, and I got sort of an insight. And I believe that the ones that are really useful, at least as a starting point, of course, I'm open for suggestion, or if you have any better ideas, I'm open to hear them. The first one is status code checks. These are checks who are trying to find out if the correct status code was returned. The other one are called structure checks, which are trying to test the structure of the response that we're getting, if the data that was provided was the correct one, and the scenario checks, which are trying to experience the API from the perspective of a real-life user. So, a couple of examples of these. I made a really terrible rookie mistake whenever I was doing my presentation, and it was that I created screenshots in the dark theme of my IDE. So probably at the back rows, it's terrible to see these. I'm sorry. And I'm taking full responsibility for this. But it's a really simple test using Codeception. You see the... Oh, actually, can try that. You see the pre-setup, which is we are creating some sort of order. This is actually our order system. We can you can order some sort of hosting in our application. And for example, you are creating some sort of payload, and you're using the send post method, giving it the endpoint and the payload. Now, Codeception is working very, very simplistically. They are having this actor class, as I said, and normally using Codeception's I don't know, nomenclature, we are instantiating it using this I actor. So normally this I actor is having all the classes that are creating some stuff like, for example, send post, send get, send delete. They're also having these assertions that you can perform. For example, see if response code is whatever, or see if response code contains specific data. So practically what we are doing, we are setting up some payload, which is created using our data generators. These are the classes that I mentioned that our developers helped us to perform, or they were partially written by me, partially written by our developers. But we are creating this test data. The send post method is the internal Codeception method, which is responsible for sending post requests. It gets two params. One is the endpoint, and the other one is the payload. And we are just asserting if the response code is okay. Very simplistic, very short, very clear to understand. The purpose of this test is to only verify that status codes are produced correctly. They are not caring about data, they are not caring about anything else. Of course, this has pros and cons. Some of them are that, for example, it's very fast and easy. It's very easy running, it's very easy to understand and very easy to read. It's very definitive because it's a yes-no answer. There is no ambiguity. And it's very good for work as a very good as sanity or smoke test. For example, if you're having developers checking in very often new code, you can have this as a fast regression suite that can be executed or triggered on submit, so they can have a very fast feedback if they didn't break anything around status codes. But it has some terrible cons. For example, it's a very shallow level of testing. Like, the status code is not something It's practically just something that tells us if the service was operating properly on its own, not something that is giving us a complete understanding whether or not it returned the correct data. It checks for get methods. For example, very often we are using get methods to get some sort of data and reuse it in our interface. So for example, getting the response 200 on a get method doesn't really help us, for example, because we don't know what data was returned. And they don't expose serious problems. As I said, if we are catching problems with these sort of checks, they're probably something very blockerish, but they are not something very complex. So they are not good for complex testing, but they're fast and they're very easy to produce. I mean, whenever we were creating new endpoints, these are very easy to produce and very easy to test, and they're helping our developers whenever they're checking in new code. So in order to fill the gaps, we are using the so-called structured checks, and I believe these are kind of hard to read. So I'm going to walk you through. The structured checks are practically using, again, internal methods that Conception has. And Conception has this cool method called IC respond matches JSON type. They have this for JSON. I believe that they have the same for XML, but it's implemented in a very easy way. For example, you can provide sort of a key value array, verifying that any element returned in the response is of specific data type, or is of specific format, or is of specific, for example, regular expression. Like, for example, you can verify that the ID is a string, or the last four is a string that has a regular expression, for example, ending up in very specific digits, or is exactly the 4 digits. You can also use ranges, like, for example, priority might be integer between 0 and 4, and so on and so far. This is not something that's, I don't know if, for example, frameworks like Rest Assured have this, but if you don't have it, you can easily implement it. It's something very easy. The reason why we are using this is we don't want to assert specific data, because specific data is very brittle. For example, if I assert if the response in ID is 3, I might change my data, and this way I'm making my test data dependent, which is a bad idea because it will break at first possibility. So we are trying to sort of only understand if we are having all the data that's provided. And this is a good idea whenever we are having responses with a lot of data and whenever data is useful. But again, this has pros and cons. It's very good to verify data. It can be very specific, especially in the case of Conception. It has really good implementation about, for example, trying to figure out if the data that was returned is the correct URL. They're having this as an internal function. You can use regex, which is great for trying to get some data that's very complex, but it has some downsides as well. For example, it's useful only for content. If you don't have content, it's practically just uses. It really sucks with variable data. So for example, if you're having a parameter in the response that's optional, for example, you're having, I don't know, create card that's optional, it will just fail the test. It's also very tricky if you try to test a response that has very deep nesting or has a lot of data in it. Your tests are practically getting very, very lengthy. And the last one are the so-called scenario checks, and the scenario checks are the ones that we are trying to perform in a way that our users would use the application. It's actually a pattern that I saw by Alan Richardson. Alan Richardson has a book called Automation of Web Services or something like this. I have it in the resources in the back of the slides. So he was using the term, using the API as an app. So practically what we want to perform in these tests is trying to call all the services in the sequence and in the way that they are going to be consumed by our client. So this is practically a very simplistic test, which is trying to test our functionality about reset email or reset password. What we are doing in the application, we are having the login form, we are having the reset password. What you have to do is go to the reset password, input your email, click on the send me email button, and you're getting an email with a very long code that you have to copy, go back to the form, copy paste it, and you're getting as a response the form for resetting password. So we are doing this with an API check. We are calling the endpoint for resetting for a password reset, and we are providing it with an email. It should be a valid one. We are using a tool. We are using a tool called what was the name? Mail catcher. So mail catcher is a tool that is hosted locally, so it catches the mails. It doesn't let them go to the real mail server. It just bypasses your mail communication. So we are getting this, and we are using its REST API to extract the response, and we are extracting from the response using a regex the code specifically. And of course, after that, we are getting the code. We are providing it to the send post past verify code, which is actually the one that's going to verify if this is the correct code. And we are checking if this is the correct condition and if it returns OK. This is a very simplistic scenario, and scenario checks are the one that might be very useful if you're trying to make sure that your API is working according to your client's expectations or whatever your specification is. But they have gaps as well. So for example, this as a test is the closest you can get to client interaction, the way that your clients are going to use your application. It can expose some really serious integration problems. Like, for example, you're calling this service and something messes up with the call, and you're getting no response or something that is a no value, and you're passing it to another service, and you see that the other service is throwing 500 because you provided it no. It exposes some really interesting problems with bad data. And it can be used as a shallow regression suite, although I don't trust such a sort of automated regression. I believe that regression should be done in a different way every time, trying to explore the same functionalities. The problems that we have with scenario check is that they're sometimes slow. They're slow to develop, they're slow to run because they have a lot of steps. They're slow to develop because in order to develop them, you have to have very good abstraction over your framework. Like, for example, if you're wanting to perform something, you should probably build some sort of helper methods or helper classes or base classes that are going to help you develop these tests very fast. Whenever you're having more complex scenarios, you don't want to repeat huge portions of code. You'll probably try to move them to common methods. And it's hard to say whenever it's too much. People get very... it gets very cool to do this, and whenever you have to do it, you might sometimes try to perform this so-called end-to-end testing, which sometimes is a terrible idea because it has a lot of steps, a lot of conditions, a lot of things that can screw up, and they're very hard to maintain and they're very hard to extend and support. So a little bit about the framework that I created. It's another diagram that I believe is terrible to see at the backside, but I'm trying to walk you through it so you don't have to squeeze your eyes and see whatever's on the screen. So we have the pre-setup, the first section, we have the pre-setup, which is normally what we are performing before we even run the tests. And the pre-setup is normally, I can actually go and zoom it a little bit. No Internet Explorer. Now that's better. Right, so we have the pre-setup, which is over here, and we have adding the headers. Like I didn't explain anything about the headers, but normally that's something that we are adding in this pre-setup because headers are needed whenever we are performing something like a test. We are also creating the test client, and that's the setting up of the test data in the pre-setup because we don't want to have this in our test. That's something that's not belonging to our test. That's something that is sort of a previous job or prerequisites that we have to perform, and also performing login, especially in our context because it's an application that is requires you to be logged in. There's a couple of special cases when you don't have to be logged in, but in the general case, you have to be logged in. Then you have the type of checks, and this is something that I walked you through, the status code checks, the response structure checks, and the API as an app scenario checks. Then you have the structure of a check and the structure of a test, which I suggest to be a very simplistic one, the one that is called the AAA principle, which is arrange, act, and assert. Very simplistic, very easy to use. Don't try to make huge scenarios of arrange and assert and arrange and assert and act and arrange and assert and act and arrange. This is something that gets very brittle and can screw up very bad. And of course, some sort of post-run that probably might be related to clearing your data or bringing the data back to the state that you want it to. This is something that we were not performing actually, because when you're using containers, it's very easy to just destroy them and run new containers. So, a little bit about the supporting classes. I believe these are visible. The supporting classes that we created, or especially that probably that I created, were some of the classes that I believe were useful for me. I don't know why. Maybe they're a terrible idea. Maybe there's something that works only in my case. But for example, I created this file of constants called API endpoints, which I believe is very useful. Whenever you're going in the test, for example, you see that I'm not passing URLs or the endpoint as an open string anywhere. I'm providing constant. So I believe that it's a good way to organize your code. I just moved all the endpoints into a single file. So whenever I have to edit an endpoint, I know where it is. I don't have to go through all my tests and look for it and replace it and screw up 10 other things whenever I have to edit an endpoint. Another thing is the data constants. There's simply some data that you're using over and over and over again, which is not related to your users, which is not changing, so you can move it to a data constants class, so you don't have to worry about it again. Extensions of API tester is something very interesting, because Codeception provides you with opportunity to extend the actor class. As I said, you're having the actor class, which is performing some actions on the API, and you can extend it. So for example, you can build your own functions, like for example, creating a client or creating test data or whatever you need. So for example, this is something that you might use. And any kind of utils that you can use to generate data, to generate orders, for example, profile data or whatever, this is something that we also used. So a few ideas that I believe might work and that worked for me. And because, as I said, I have this cringe feeling about best practices, I call them worst practices. So these are practices that nobody speaks about, but I believe are very useful. And I'm not going to present them as they're the best one. They're simply the ones that work for me. So first of all, incorporating OOP principles in writing your API test are something that helps a lot. Of course, that's something that sounds understandable whenever you're a developer, but whenever you're not natively a developer, whenever you're doing testing mainly, you might run into certain problems trying to develop a good inheritance, for example, or reuse, or trying to keep your code simple. So, as I said, what really helps in these cases are having a developer friend or a developer consultant who can give you advices whenever you're trying to do something in a bad way. Try to incorporate code reviews. They help a lot, and they mainly help the person that's reviewing the code, not the one that's being reviewed. That's very useful. Try to scale in a matter of inheritance. Try to organize your code in a way that you're reusing the functions that you're already having, not trying to repeat them. And especially in PHP, we can use this sort of horizontal inheritance. Like, for example, you're having a function that's not necessarily inherited, but is simply there and there. There's no specific way that you can trace it, so you can use it as a trait. That's something specific for PHP. One example of the inheritance schema of our code is, for example, we're having I decided at some point that I want to move the logic of my application away from the logic of my test, so I only have the tests in one file, and I have the logic of the test, the logic of creating the test or test data in a base class. So for example, I have the base test class, which practically holds any data that's common for all the tests. This is whenever we are giving the headers, for example, because that's something any test would need. And we are having these common functions, for example, for encrypting and decrypting IDs, something that any test might need. And we are moving down the inheritance. We have the base client, whenever all the client-related actions are. For example, the create client is here, the login client is here, because, of course, if we don't have the client, we cannot log it in. Then we move to base account, because client has accounts in it, and we are stacking this, and for example, whenever we have created client, we can move to creating accounts or do any related account actions. We have the base profile, which inherits again the base client, but it's on the same level as base account because we can have profile without having an account, or we can have affiliate without having an account. And the same with credit card, because we have credit cards, but they are not related to accounts and so far. A little bit of, I can use this zoom again. A little bit of the before methods. Before methods are something that are, for example, the setup of our tests. And the before method that we use here is kind of reusing the data from the previous one. So for example, this is the before method of the client. We are already reusing the code from the base class, which, as I said, practically just adds the header. That's the reason why I'm not showing it, because it's nothing interesting in it. So, for example, we are reusing it in the before method of the client methods. We are creating client. We are setting some variables that we might use further, and we are authenticating as these clients, and we are seeing how this is inherited from the account method, which is the before in account method, which reuses the create client. It reuses the code from the create client. It creates some accounts. It sets some data that are needful for the account methods, and so far. I'm running out of time, so I'm trying to rush it a little bit so we don't go out of the time that we have. So let your framework mature, something that's very important. I'm not a professional coder, and I believe that the developers among us are aware of this, but the testers are not probably. So your framework will suck really bad at first, and that's completely normal. Don't try to over-engineer it, because it doesn't work this way. You're not able to create the perfect code from the first time. It's something that comes in time. Whenever you're seeing something fail, you're trying to improve it. That's the normal life cycle of your code. You don't have to do it straight up. Try to split the logic of your application from the logic of your tests. Don't try to do everything in your test. The more you reuse your code, the easier it is to produce different types of tests. Move common actions and common functionalities to base classes or to some helper classes that can provide you easier performance. Build inheritance trees and reuse rather than repeat. Couple of useful resources that you can use. You will probably get them if you go to my blog or if you get the slides after the conference. First of all, the Hindsight lessons about API testing blog post that I wrote, which is practically whatever I said here, but probably a little bit more high level. This was a little bit more supported by examples. Automation and testing a REST API, book by Albert Richardson. That's the book by Albert Richardson. There's this article by Smart Bear, which actually gave me the idea because they split the logic between status checks and scenario checks. So I extended this idea a little bit further. The Service Virtualization Guide by Bas Dijkstra is a free book, which is very useful whenever you're depending on some external services that might be third party you don't have access to, but you have to mock. And of course, your brain. Whenever you are using something or whatever you are trying to test something, please use your brain. Don't trust anything blindly. So thank you very much. And I believe I would have a couple of minutes for questions. Any questions? One there? No, there's a microphone running to you.
Thank you for a really pragmatic and refreshing talk.
Thank you very much.
My question is, just in the spirit you mentioned separating the test code from the development code, would you recommend testing code that is written in different, like Node.js, Java, enterprise solutions with PHP framework? So what will be the problem with that you see immediately, or is it advisable?
Yeah, well, what I was speaking was not actually splitting the development to the testing code, but splitting the logic of setting up the tests and running the test itself. But what you referred to is a very common question, and well, it all depends on whatever you're having as expertise. Like, for example, if your testers are having Java expertise and your developers are PHP, they would write Java tests, and that's simplistic. I believe that it's useful if you can reuse the expertise of your developers helping you creating your framework. Like, for example, the helper classes that I was using, creating the data, first sucked very bad because I was using the API tester, and we were practically coupled with API tester in every setup class that I was using. So we tried to export these and give this to a guy writing UI tests, and they sucked because we had to import the API tester in a test which normally use the so-called acceptance tester in PHP. So our developer helped us splitting this and writing it completely in a PHP framework called Guzzo, and we were not depending on this API tester anymore. So developers can help a lot. Of course, sometimes they can screw up things very bad. Like, for example, they can over-engineer stuff, or they can make them so profoundly expert that you cannot understand them and you cannot use them. But of course, I believe that a second opinion and their input is very important in this case. So if you can use your developers, if you can write at the same framework that they're using, it's very beneficial for you. But if not, it works again, of course. Does that help? Thank you. Any other questions? Okay, I will be here until I believe, the afternoon of the conference. Thank you very much for coming, and see you around.